which then to the system. Done for redundancy, and they're also often done just for pure. You need more. You will quickly. Huge number of passes. The fabrics themselves get redundant as well. Typically, you have. Another way of connecting is direct attached DAS lower in systems, and here you'll have just the one. Once we eliminate the fabric, we just go to the device. Sometimes there's also something called JBond that's even below this, where literally specifically to the disk itself. Typically in architecture you'll see in systems, small medium business. But even increasingly, I think it's probably being okay. And this is the area where because the cost model tends to we talk about there's some performance points that I mentioned that often that you'll have coming in because of performance through inside the system. You again and there's things that are done to and reliability and responsiveness to the system. Well, here you can see what they've done is rather than having us that everyone's talking to, they've actually inside and isolated the system into two separate subsystems, if you will, with the common. And this is done for capacity and performance. Common bus, you can saturate that bus. Here's architecture where you can overcome. My purpose for showing you this is a lot of intelligence and each best way of doing this to bring performance and reliability goals and approaches to this.
And when it comes to you put more componentry in there, picking up the intelligence that component itself will look like it has a profile, but a solution of server network storage, your power being identical when you put that as a solution. It's just letting a physical piece. And this sensitive area where some vendors be like a unit of product that if you were looking at a label would provide a misleading set of information if that was the only information that was making the decision criteria.
In addition to performance and a typical controller will bring capabilities. I'm just going to touch on, for example, virtualization. This is a technology that can be in the controller. It's actually out in the fabric that allows you to create a here's that they're talking to a disk, but it's actually just a virtual disk. The virtual disk behind it may be spread over, may even be spread over multiple systems. I mentioned before about the tier where you may have a very high performance storage, range performance storage, the very high, if you will, transaction, whereas the mid-tier energy cost per transaction appropriately place your data. Well, this is technology that can allow you to migrate data that is really important on that high performance one, and then now is actually migrated transparently to and the applications and that stuff actually got moved from the virtual environment. Technology that can be applied. There's other technologies coming down the pipe. Just thin provisioning was mentioned before. Thin provisioning is a Gmail account. You get 200. I'll guarantee you that Google 200 gigabyte drive sitting somewhere waiting for email accounts. What they've done is they'll use a level of I have 200 gig, but they're only physically. And then when I limit, then they'll allocate me numbers. And there's some intelligence that does that mapping of when you've reached the limit, automatically, or is by the operator. Here's the technology that inside of these controllers or inside of the fabric. There's different places. I think the last thing that I wanted to, again, this is a very high level primer, is RAY. You're going to hear RAY. Technology is all used for to achieve both performance goals. And I'm not going to make us experts on the rays. Interested, we can send you different types of rays. They have different characteristics in terms of their ease to performance, their reliability, faults, as well as their from an energy standpoint. So here's a tutorial thing. It's kind of cute, different ray things. Just your standalone drive, you can have hot swap. Clustered where you have two exact mirrors. These are different combinations. Here again, the key message we want to get across is the feature within supply. Very pervasive. Storage device isn't fixed which one of these it does. It can be configured in one or multiple of these different RAID capabilities, and it's up to the operator to decide which one to pick based on their goals for performance, reliability, operational costs. And I think we've only got 2 more slides. Again, keeping on the RAID thing, it can be done internally to the controller itself, in the storage device itself, or for lower end systems, that RAID functionality can actually be performed in the server, either on the adapter card inside the server itself, or even with software-based RAIDs. So, as you can see, hopefully this information was helpful to you as you go through your data center where you can see some of these things. One of the things I wanted to get across is there really is a wide variety of storage subsystems, from fairly simple ones to very, very complex ones, and they're done for a reason to achieve different performance and reliability. Is there any questions, comments from the fields? Great. So I think Phil's going to talk now more about specifically what green storage is doing inside SNIA.
Thanks, Al. So just from a consumption perspective, from a market consumption perspective, I think clearly from the technology that you've been introduced to and got some really concept in, it's the intelligence that has grown, more importantly been designed into these storage arrays that is really driving the resiliency of data centers today. So, and naturally, we're here to discuss, it comes at cost, right? Cost of energy, hard cost, CapEx, OpEx, etc. But in most cases, it's the design that is somewhat more paramount. The decision about purchasing those designs is equally, or in some cases, more important than the server choice as well as the application choice, right? So those are some of the market factors that are driving these designs and the resiliency that you see. So what I'm going to do is take some time now to talk about the activity, and most of the folks in this room are involved in the activity around the Storage Networking Industry Association's green storage work. So I just want to take some time to highlight that and give you a sense of sort of some near-term, longer-term work and how we plan on facilitating that. So amongst the folks in this room, there are a number of very market prevalent leading storage systems manufacturers involved in this effort in the SNIA Green Storage Initiative. And also it includes the supply chain as well. So not only the vendors that are selling directly to end users, consumers, but the component manufacturers as well. So there's a matrix of partnerships here amongst us from a component point of view. So given that, and once again the quintessential triangle slide, but just from sort of a simplicity here, the complexity, which certainly you understand, it was probably like drinking from a fire hose during Al's presentation, but nonetheless very important. The complexity drives resiliency, performance, availability, and the market spectrum at the bottom here, the number of units. So from where we're working right now, the Green Storage Initiative, covering pretty much 80% of that market today with the work that we're focusing on. Now, as we mentioned, yes, we do cover, as an industry association, other types of technologies, tape, optical, the storage networking technology, fabric technologies that Al spoke about as well. But our work so far, or the beginning of our work, is focusing on that high capacity, high drive count, disk drive count system, hundreds or maybe up to 1,000 drives, multiple power supplies and redundant systems in these arrays. You'll notice something that really hasn't been brought up yet is this category of quote-unquote web or mass scale storage, and that's an emerging market identifier for grid mass distributed storage. But I will submit we're not working on that category just yet because it's emerging. So because of that 80% of the market, the area that we're focusing on for our green storage work, that we feel that the industry as a whole can make a great impact quickly on power, cooling, and efficiency work. And I do want to stress that, as we talked about earlier with the EPA folks, that yes, this team is working or interested in sustainability as well. For purposes of this discussion, talk about the power, cooling, and efficiency aspect of our work. So the Storage Networking Industry Association Green Storage Initiative is split into basically two working bodies. One is the Technical Working Group, and you may hear the term today, the acronym TWIG, as you'll hear many acronyms so far, right? And so this team made up majority of those vendors that I highlighted earlier, and focusing on driving, developing, and understanding benchmarking considerations, measurement metrics for power, cooling, energy, efficiency, the categorization that we talked about, the different levels of storage, storage arrays, types, and the market fit that they have, and stratifying that. So the opportunity to not only understand how we can measure and define standards for the industry as a whole, but also future design efficiency, and collaborate on that in terms of standards for reducing or increasing efficiency from power and cooling. In addition to the working with organizations as far as leveraging the potential design of particular instrumentation that may come into this activity as well. So these are early efforts. I'll get more specific on some of them here. So I talked about sort of near-term and more longer-term activity. So the body, folks on the phone, folks in this room that are already involved in these categories here in the near term, working on understanding metrics, understanding the energy consumption profiles and efficiency profiles of our existing storage. And I'll submit, as I show you later, there are technologies available today that we're delivering as a whole of the market that are driving greater power and energy efficiency. But once again, so this is baseline activity, to be able to get that snapshot of where we as an industry, our equipment is as a whole from an energy usage metric perspective. To define, develop that eventually into generally accepted standards for the industry with regards to the categories of consumption, power usage, and efficiency. And ultimately, obviously, to filter that out to the community as a whole in terms of how to be more efficient, leverage, teach them about these new standards that have been developed, accepted, and adopted. And additionally, moving on to new designs for, or recommendations for more efficient designs. So I just wanted to highlight that as activity that is taking place today. And in the future then, to define operational measurements. So how can the user, the consumer, interact with the technologies to define or be more efficient in the operation in accordance with the standards that have been developed, in accordance with the features and functions that have been developed as well. And then moving forward, working cross-industry and potentially, as we talked about this morning, the commercial building effort as far as potentially reaching out to other elements of the data center for instrumentation, power, automation as well. So these are bodies of work that are now just starting to be developed in separate subgroups within the technical work group to start to work on. So just wanted to give you a sense of the near-term work underway and the longer-term work that is now just starting to emerge from this group as well. Any questions on that? All right, the second body within the Green Storage Initiative is called the Green Storage Initiative. And this is really the work group that's focused on outreach to the industry, the community as a whole in terms of education, in terms of generating awareness for this activity for the industry. So we have a number of events that we sponsor and hold on a regular basis throughout the year, as well as participation in other vendor and industry team events where we drive education, seminar activity as far as being able to leverage the work that's been created by the technical work group as well. And we leverage expertise from amongst our industry members to do that. So in addition, we're aligned with a number of other industry standards bodies. Rich, you may be familiar with some of these as well, that we have in place today and others that we are targeting. So the Distributed Energy Task Force is a consortium that's focused on operational management of not only storage but systems, networking, etc. That we work in collaboration with Fiber Channel Industry Association. We have some representatives in this room that are responsible for that. Now that's a sub-industry group that is focused on that fabric area, that storage network area, high concentration there. So the Open Grid Foundation that we have an alliance with to work collaborating with this distributed computing, distributed storage emergence now that is fast becoming of interest to the IT community. So we are now in discussion with some more formal alliances with the Green Grid, as well as other organizations that you may be familiar with that are involved in server specifications, storage performance, server performance work, as well as they're looking at us to provide them potentially with storage performance metrics as well. So naturally, with the EPA, Department of Energy, represented here today. So I mentioned earlier about technologies that are available today and emerging into the marketplace that have been developed. In most cases here, all of them have an element of energy, power cooling efficiency that they can affect, right? Some singularly, some as a whole. So we heard this discussion around deduplication and the ability to understand duplicate files, duplicate objects, and reduce that so that the net is that it's a reduction in the amount of space used, hence the consumer does not have to buy as much disk and can reduce that cycle of buying additional storage. So Al touched on RAID technology and the fact that there are different modes of RAID technology that our users and consumers can deploy to affect performance, heating, and cooling. A term emerging right now is this term of MAID, which is an acronym for a massive array of idle disks. And so this is the notion of that the user or the intelligence within the subsystem has the ability to power down a disk. So obviously the notion that a disk that is not spinning is not consuming energy. So as you can well imagine, there is some significant research there. There are technologies available in the market today that give the consumer that ability to do that. So as you can well imagine now, there are some dynamics there and dimensions on the particular applications that are suited to that, and applications that may not be suited to that, right? So Al touched on the concept of thin provisioning or oversubscribing, so that you're not using the physical space, and it's sort of an on-demand basis, so that once again you can slow that cycle of having to purchase additional disk. Emerging now also is a solid state disk technology and flash technologies that are providing now additional power-saving capabilities in the enterprise storage area as we move up that triangle. So in higher, denser recording, spinning media as well as potentially tape media. Vendors on their own have developed tools that can give end users choices that are available today to do some modeling and better understand how their purchase or the energy usage footprint of their purchase may affect their consumption, as well as the ability, as I mentioned earlier, to target specifically spin down specific drives and other practices with respect to cooling within the storage itself, and guidelines on placement, so whether they could be liquid cooling approaches within these systems or other air-cooled approaches for these systems as well. And then lastly, sort of the outreach that every one of these organizations is focused on either a direct service partnership or a consulting partnership with their customers, or other consulting organizations that can help and guide green services practices for their clients in terms of applying the technologies. So that's just to give you a sense of technologies that are available today in the marketplace that have an effect on power, cooling, and storage efficiency. So, given that, and using the EPA data, that a general sense that these technologies certainly can have an effect on now of what historical usage patterns have been for the data center, for this technology in general. But the fact now that we feel we can make a significant effect, once again today, technologies that I showed you that can slow down that growth in usage, right? Defer it, as we spoke about earlier, and then additional technologies that could accelerate that reduction in energy consumption. Okay, so with that, any questions? Once again, probably was much like drinking through a fire hose, but I hope you got a good sense of the technologies, the approach, and the work the industry body is doing here, and the individual vendor companies are doing as well to address this and move forward and collaborate.
Is this the level of information that you were looking for, or do you need to go deeper in a future date with this type of information?
Sure. This level, this was extremely helpful. I think I doubled the amount of this from the street today. So, yeah, this is very useful at this level. Clearly, we'll have to drill down a bit more, with some time. We need to be able to come up with the right questions to ask, and we can only do that by absorbing a bit more.
And hopefully this will give you a good understanding of, so when you actually see this gear and hear the comments from the folks using it during your tours, you can have a good sense of what they mean and the challenges they have. We don't take it back.
We're at this juncture point that we can clarify clarify things that we've, you know, put in front of you. Like I said, if you've seen some things that need better correlation because it just came out in a certain way to speak, you know.
Well, it might be worth, as I know, I suppose we have a little time to maybe give you some questions of things I was thinking about as you're going through this that might be useful. One of the questions that always comes to mind is, in spite of all the complexity that you mentioned, which no doubt is manifest, you know, are there advantages of more efficient storage? Yes, no, maybe, probably all of those to some degree, and probably not easy to necessarily identify immediately, because it seems to me that one of the things that no one's probably, at least in the past, maybe only in the near future or in the recent past, has there been any questions asked about energy use? I mean, you may have a lot of people in your industry that may not necessarily know the question about, you know, are there advantages necessarily of more efficient products, because you've never necessarily had to ask. Just worth thinking about.
I'll give you a vendor answer to that.
Sure.
If we can save less electricity being consumed, that's more money left over.
Sure. Well, let me get to that point. The other thing that might be interesting to know is that in spite of all of the diversity of the products in the storage area and the storage market, not all of them compete with one another, because some may be more appropriate for certain applications than others. But to the extent that there are like products, it might be interesting to find out what are the energy characteristics of those like products. So clearly, speed equals better performance. It wouldn't be fair to compare products that, you know, a turtle to a leopard or a turtle to a cheetah. but for products that are more similar in nature that do compete in the marketplace, it would be interesting to know going forward what some of those are, you know, what some of the energy differences are. And again, that comes down to somebody being able to measure things, and that's not always on the tip of somebody's tongue. The other questions worth thinking about that I was thinking about is, clearly it is not an accident that all of a sudden there are many companies interested in, I guess I should be addressing the whole room, interested in green IT or green storage. Different industry stakeholders might have different reasons for being interested in this. And it would be useful to us to help understand what the range of motivations are, because we might be able to speak to some of those motivations, and then there might be things we might not be able to. I suppose that some manufacturers may truly think about things from purely an environmental perspective, probably at the extreme end of one end. You might have some manufacturers, I don't know if there are any here, but certainly in our business of dealing with many, many different manufacturers, purely it's PR. They're only interested in PR. So they may actually have good products, they may have inferior products, but they're only interested in PR. And then there are probably most companies in the middle which are interested in competitive advantage. You may care only because your boss has said, go to this meeting, pay attention to it, but you know, their own personal values may be different from that of the company. So those are things worth thinking about as we try to map on what Energy Star can help you with, where, you know, we want to find the sweet spot where we can have an impact which could help be a launching pad for your industry to make real sustained progress. So those are just some questions I sort of think about. They can be applied to any industry, for any type of product. And of course, there's always different levels of complexity depending on the product or type you're working on. So those are thoughts. I mean, anyone has any thoughts on those, I'd be happy to.
Yeah, just make a comment on the categories. I think you're exactly right. In the green storage technical working group, we've started to create a taxonomy of the different categories, so we are comparing apples to apples. As you said, we can't compare So that's in process, and we're really interested in your feedback for the types of things you're going to be looking for within these programs. And some feedback maybe in your presentation as we go through this afternoon. I could speak for my own company. I think anybody that's in the Green Storage Initiative is really intent on finding ways to conserve energy to help our ultimate end customer, because the operating expenses are far exceed the equipment itself, and maybe up to 7 to 8 times on an annual basis. So helping our IT community reduce their...
Right. Because if you don't, your competitor will.
Right.
Right. And so when we talk to manufacturers, we're happy to, I work for the federal government. It's my responsibility to give you an opportunity to speak to me. It's your right to have an opportunity to make your point heard. But, the thing we always want to make clear to people is that if your interests lie elsewhere, then the next place we go is to your competitor. So, and oftentimes we'll tell your competitor, these other folks don't care. Do you want to differentiate yourself? If so, we can help you. If you don't, then we'll move on to the next person. So that's just the competitive nature of using Energy Star as a means to, drive.
And I think at this point we're all interested in having a stake in and a say in what those standards become, so that we can first of all help facilitate the knowledge and the progression of that, and then as an industry have something that's fair and equitable across.
Right.
I want to speak from a vendor point of view. Certainly, we want to help the customers to save power, save save on the electric bill. Certainly, we want our products to be competitive, against similar products. The challenge is that most of the customers we talk to, they don't want to pay for any cost associated with power reduction. And in most cases, if it comes down to the fact that they have to pay a little bit more, they just rather buy the normal thing. And the reason being that there really is a separate people controlling the capital budget versus operation budget, and a lot of people rather just save money on the capital budget now, and then the operation, that's a later issue. And that can be paid off using increased income from future, and they rather not want to think about it. So I think that's something that you might want to be aware of. I mean, that's a real.
I'm definitely aware of it.
Yeah, that's a.
There's no doubt about it. Well, obviously the people who don't want to pay for it do pay for it. They just don't think they're paying for it.
Right.
So,
overall, their company is paying for it.
Oh, absolutely, yeah.
But the people who are buying, they're not paying for that operation expense.
Well, and that's why I hope and I think that is beginning to change, and that organizations that figure it out and figure out what's best for the entire organization as opposed to what's best for one department because they want to hoard their resources. Organizations that do figure it out and do a better job are clearly more competitive going forward because they figure these things out. But and those that don't get left behind, and so the vendors that are able to help them overcome that. And clearly, I think one of the ways in which you make the sale to do something more efficient is you have to figure out collectively how you make it more transparent to the customer what the energy costs are. You go to fill up your car, you get smacked in the mouth because it's really expensive, and you see the price right there, and you pay it. When you pay your utility bill, you tend not to save as much because it's 30, 60. I just got my utility bill from Puget Sound Energy. It comes once every 4 months. So I had no idea what my bill was going to be. So it's clearly a little higher than I expected.
Yeah.
So
I think the Energy Star thing is great if there is a little line to say that you're going to be paying this much energy bill, moving forward. Then yeah, it becomes a.
Well, the other thing to remember is you have a real diverse market. Energy Star might, and and I stress the word might, be appropriate, might be the right market intervention for certain segments of the marketplace. Probably can't be applied to everything, and it probably can't be applied to everything immediately. We have to bite off small chunks. And we've done that in other market areas. One area which is probably on the opposite end of the spectrum in terms of complexity to some degree is commercial food service equipment. You know, a lot of restaurants, a lot of hotels, a lot of prisons in this country, they all have big food service operations. And that industry, they can't get Energy Star specifications fast enough for every type of piece of equipment. I mean, if they could write them themselves, they would, because the stuff, it really, for the first time, has cut through a lot of the complexity for the customer. It makes it very easy for them to figure it out. So they really want all sorts of specifications. But, you know, like anything else, we have limited resources, and one of the things, you know, I like to talk about longer term is how do we work together to leverage your technical committees to move ahead aggressively as necessary, but you can only do that if you know what we need in order to in terms of the foundational elements of specifications.
The other element there, I think I mentioned, it's another track that EPA and DOE are pursuing is not the equipment level specifications, but the facility level metrics and assessment protocols. So, one of the reasons there's not customer interest is, as you say, this division within the organization. So, in a sense, you need to raise the visibility of the data center and the energy use of the data center, and having these metrics and this information is one way of doing that. So the product metrics are not the only strategy that the federal government's taking to address this. There's also this parallel track of trying to do this facility level metrics.
When companies, and we're starting to see this now, miss corporate-wide environmental and energy goals because of the data centers, and I mean, we saw that with the big British bank last year. I mean, they pointed to that as the reason for their corporate-wide failure. Then things start to change. And really, it's not really about blame. It's how do you find, what are the easy ways to improve your score? And there are easy things to do, and there are hard things to do. And so if we can figure out a way to make some of those decisions easier, I think that helps to move us closer to the tipping point.
There is another issue that we've run into, is that the people who are designing the system, oftentimes their requirement is on the performance and not necessarily on the power. Because again, those designers are not responsible for paying the bills, moving forward, right? And so I was personally shocked. I can't name companies or whatever or imply anything even. That there are some vendors out there that decide to rather use only actually half a drive, just the outer diameter of the disk, for example. So use it at half capacity. So basically, to get a higher data rate, and then so they end up powering up 2 spindle, for the benefit, for the data capacity of 1.
Right. And certain customers may want that for whatever
Right.
whatever reason, but others may not.
Well, fundamentally, I think that raises a really important point. Assessing energy density for an installation, whether it's at a single spindle or an array or an entire data center, can only be meaningfully done in the context of a workload. These things are actually not just pretty, though if we could sell them that way, we would. Let's quit kidding ourselves, but they're going to get business work done. And so you need to define a context, a business context, whether it's a performance level, whether it's an application mix, whether it's a user transaction profile, whatever it happens to be, against which to do your evaluation of energy efficiency. If the thing is enormously efficient when it's idle, but your users are actually hammering it at 300 IOPS the spindle, the metric is meaningless. It's only in that context.
Idle a lot.
Well, if that's an appropriate metric for you, if that's the appropriate environment for a certain storage, and that's absolutely the case. It'll be ice cold 300 days a year, but then suddenly it's April 14th and the IRS disks are spinning like hell, or the equivalent, right?
And that type of thought process is going into the technical work group. We've also looked at coming up with best practices, which would apply to the data center to give easy, going from easier to harder get the low-hanging fruit first, make those best practices recommendations. Long-term goal is to do metrics, monitoring and control of the storage infrastructure, the storage system, so that people can have that dashboard on the monitor that says, hey, unit 10 is using 20 kilowatts too much, I need to do something about that. But that's a longer term.
Yeah, and that might frankly be an area where the government has no interest or role at all. I mean, it's hard to predict for sure, but the reason you would want to do all of that, I suppose, is that the cost of operation gets considerable to the point you want to give that extra manageability to your customers. And price has a funny way of making people change their behavior. But we sort of have modest goals to start with, rather than some of the more complex stuff.
I think this will be a good point to break and grab lunch.
Thank you, Wayne. Hopefully everyone can hear me. I think it's fine. I usually talk pretty loud.
That mic on too.
Yeah, okay, I'll talk to that. Put a pen in my hand. It's a little bit of a crutch. A couple of notes here.
For your segment, do you want to like deliver? Do you want any question here and there? How would you like to run that?
I think it's fine for people to ask questions as we go. I don't have a problem with that, and let's do that.
And I think there may be some new people in the room, and plus maybe new people on the phone. Maybe just take a minute to introduce yourself again.
Sure. My name is Andrew Fanara. I work for the US EPA, and as I mentioned, the Climate Protection Partnership Division, CPPD. Under CPPD, which is an umbrella program, umbrella division, there are several segments including Energy Star for products, Energy Star for commercial buildings, Energy Star for new homes, Energy Star for industrial facilities, and those are the primary areas where Energy Star has been applied. I mostly work in the area of products. The team I've been leading helps to write the technical specifications, test procedures, data gathering for Energy Star products, and we'll talk a little bit more about that. So why don't we go ahead and launch into that. So this is just a list of things we'll talk about today, start basic and drill down into some of the more specific content, and then broaden out a little bit and talk about some of the international harmonization. By the way, how much time do I have again? Or how much time are we going to take?
Roughly an hour, but if we get a lot of Q&A, we'll run that to that point, and then we'll run this out for 3.
Great.
If you can stay later.
I think we can. I think we have some flexibility.
Because we have no hard stop here.
Okay.
For this room.
All right, good. Okay, so ask questions at will. Okay, so let's start with an overview of the program. Again, I'm joined by Arthur Howard of ICF Consulting. ICF is our prime consultant to the Energy Star program. They have folks who help us in a variety of capacities running our program, implementing our program, as well as on the research side. ICF oftentimes will go to subcontractors for more specific needs that we have when we're trying to gather more technical information. I'm also joined by Rich Brown, Lawrence Berkeley National Labs. LBNL is part of the National Lab structure, which is part of DOE. And the National Labs, which in my view are real treasures, and I think the envy of a lot of other countries in terms of how we organize our research, are really a big help to us because they're able to focus in areas that really take long-term sort of perspective and analysis, and LBNL has been working with us for about 10 years on end-use forecasting and a lot of things across a variety of sectors. So they really help us figure out energy problems or energy issues which often come up when we're trying to figure out how do you create Energy Star programs for very diverse sectors of the economy. So Rich is here, and he also gets, again, the credit, infamy, etc., because he was the lead author on our report to Congress, which we published back in August, and I think it helped to catalyze and create really a lot of activities around people caring about energy consumption in the data center. So the last 36 months or roughly have really been intense times with respect to this issue. The report helped, I think, get people focused, and now I think there are a number of initiatives going forward, including this one, which I think are very compelling. So let's move on. So Energy Star really is a broad portfolio of strategies applied to a bunch of different areas. In the area of products, where I tend to work, we've got many manufacturers who make lots of different products. Oftentimes, on average, those products are significantly more efficient than their conventional products. However, these are products sold in the marketplace right now. Energy Star is not about telling manufacturers, go out and make a military-grade product and try to sell it in the marketplace. We're not interested in doing that. We're not really interested in the cutting edge. We hope by focusing on the most efficient products now that they help to sort of nudge the less efficient ones from the marketplace, and that helps to draw in some of that future, more cutting edge technology down the road when scale can be applied to it and costs be driven down and hopefully make it more mainstream. So we have products, we have Energy Star Homes. Interesting fact there, I think, in spite of the serious decline in the housing market, some of the homes that are still selling well, and those that are built that are holding their value, happen to be ones that our Energy Star have a lot of other sort of environmental attributes. I think that differentiation has been a big benefit to certain segments of the housing industry, to home builders. So that's been very interesting. Hopefully, in the long term, Energy Star homes will come delivered with certain Energy Star products, appliances, lighting, HVAC, etc. We're moving in that direction as a platform. We also are trying to convey information to people that where there's not an Energy Star product per se, there's certain things that you can do to make your home or your business more efficient. Better insulation, seal your ducts. I'm looking at Rich because he knows a lot of stuff too. There are lots of things you can be doing beyond just buying Energy Star. So it's not just about going out and buying a better product, because if that were the case, you would find that our commercial building population in the United States would be a lot more efficient than it probably is. It's a lot about maintenance, it's a lot about operations, not just about technology, and that's something that we have to keep in mind. On the commercial industrial side, I don't know what the number is now, but a significant amount of square footage in the United States are buildings that have been benchmarked with the Energy Star benchmark. So we have Energy Star benchmarks for supermarkets, warehouses, commercial office buildings, schools, different types of buildings, different types of metrics. People are benchmarking, trying to improve their score every year. This has been something that certainly real estate management companies have really embraced, because if they have a big portfolio, they're trying to show their clients that, look, our buildings are better, there's value added here, so come to an Energy Star building. I think we could probably take a little bit of credit for helping to spawn, to some degree, the LEED building certification program, which is run by the U.S. Green Buildings Council. A lot of the folks that worked in Energy Star in the commercial side of the house now are working at LEED, and LEED has really taken off. And of course, LEED is more expansive than just energy, but again, a lot of focus on trying to make the population of buildings a lot more efficient. Okay, so what do we want to try to achieve when we're writing specifications? What does Energy Star mean when I use it? What is it a euphemism for? Well, there are objectives that the agency, that EPA has, and then there are different objectives that customers might have when you buy those products. When you buy a refrigerator, you want it to refrigerate your food and not have it spoil. When you buy an Energy Star refrigerator, the agency, the EPA, wants you to obviously have a good refrigerator, but to have it do it in the most efficient manner possible, because that's important nationally to national energy goals. So, you know, increasingly we're trying to reduce, well, at a minimum, stabilize and then reduce greenhouse gas emissions. Huge, 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 world-changing event. I mean, it seems pretty innocuous here, but this is a gigantic task, and it will probably change a lot of the ways in which we live, in large part because we have no conception about how important energy is in our daily lives. We simply, it's almost incalculable, because it is so important and so omnipresent. So, we use energy more efficiently. There's lots of benefits to the economy. Public health is one of them, and that's the primary mission of the EPA, is to protect public health. We use energy more efficiently, we have less air pollution, et cetera. Those are benefits as well. We also, you know, we sort of, number two is sort of a means to, if we can make it easier for people to make smart purchasing decisions, then we can help them, we can help achieve our goal of reducing greenhouse gas emissions. Oftentimes, we'll get rooms of manufacturers where we'll say, well, you want to know, my customers don't really, maybe they don't really care about this, or I don't care about number one necessarily. It's really not on my radar screen. Not because they don't care, but it's, maybe that's too strong a term, but it's not a driving factor in what they do every day. And what we are trying to do is create competition on efficiency, which if that happens, then we'll achieve goal number one from our perspective. So I don't lead with, hey, save energy because you want to help the planet. You have to run businesses, sell products, please your customers. If selling more efficient products helps you make them feel better, helps them lower their cost of their bills, then we'll all be better off down the road for environmental purposes. So Energy Star, what is it? Distinguishes what is efficient and better for the environment without, this is presumably the thought, no sacrifice in performance. It's a voluntary program. It is not compulsory. You don't have to do it. The 1,700 manufacturers that are currently in the product program, they do it because, for a lot of different reasons. So that's important. We've got criteria, which you determine that you meet when you complete a test procedure to see what the performance of your product is. When you get your score or get your number or whatever it might be, then you determine whether or not you're Energy Star or not. So it's generally sort of binary, yes or no. And you know, we have a testing program to do verification, but generally right now it is a program of self-certification.
Andrew, can you go back a second?
Yeah. Oh, yep.
So your bullet number one there, say if we go to nuclear power, that pretty much goes away then.
Yeah, that's true. I mean, that would be a huge step for the economy. I mean, there's no guarantee we can get there.
But what I'm looking for is, so you really are, I mean, you're part of the climate office, you're part of the climate program, you're less concerned with energy use other than a driver of climate change.
Yes.
Okay.
Yes. Yes. I mean, it's complex, but at the same time, I mean, I think we tend not to. We're not ignoring the realities that we have right now, which we're sort of stuck with the system we have. I mean, whether or not you're for or against nuclear, I mean, if we all agreed we could do it in a safe way, it would still be decades before it would be able to scale to the size that would be necessary, which would be great because it would reduce greenhouse gases. It might introduce other issues, but...
The point is not just nuke. I mean, clearly anything that, for example, would use wind power, tidal power, hydropower, geothermal, the more that gets used, the less relevant Energy Star becomes under that definition. Right.
That is absolutely the case, and I think up until very recently, I think, well, EPA was, at least initially, one of the biggest buyers of green power. We've been edged out now by other companies who are just quite a bit bigger than ourselves. We are the biggest advocates of renewables. I think last year, wind was the third largest contributor to new supply, which is fantastic and great. It's just off such a small base. I mean, I always make this case that every talk I do, I pull out the paper that they leave on your door that day. And in almost every case, there's something about biofuels or renewables or whatnot. I mean, they're barely a rounding error. I mean, we have so far to go before they are a significant contributor. But the only thing that we really have in the near term is efficiency as a serious means by reducing our energy consumption for any number of reasons why we may want to do that. So, I don't know, is there anything you want to add to that, Rich?
Well, yeah, I just think economically, efficiency is far and away the least expensive energy resource.
I'm not disagreeing with any of
Yeah.
that. I'm just,
Yeah.
the whole point here is I don't remember the genesis of Energy Star being climate.
Oh, it
Yeah,
wasn't.
it's
In
always-
fact, it is only recently when we could use the term climate. We were not allowed to use the term climate change in memos, materials. It
Yeah.
was strictly forbidden.
But,
But the enabling legislation is the Clean Air Act, right?
Yeah,
Isn't that
yes,
the-
yes,
so it is-
the Clean Air Act, yeah.
right,
Right,
which
so it
certainly
is about air pollution.
antedates the current administration.
Yeah, yeah. Well, I mean, even, I don't like to comment on politics, but I
Good.
think things have changed a lot, even in the current administration.
Yep.
So, yeah. So, yes, Clean Air Act was the enabling legislation. I mean, you know, they think 1 million people die prematurely in China every year from bad air. I mean, it's a big health problem as well, so.
Andrew, you mentioned that this performance criteria, the testing is a self-certification or self-testing process in most cases. So is it just a prescription and procedures that you put out and then the test, those are free to get and then you go off
Yeah.
and do them and you submit
I mean,
them?
generally our test procedures are not terribly onerous. Some products, they can be done on a bench if it's an electronic product. Some of the products have to be sent out. Some of the products, the information, the energy piece is gathered because they have to test it for other reasons. The air cleaners, again, an example. You submit an air cleaner for verifiable third-party testing. When they run the test to get the clean air delivery rate for pollen, smoke, some other type of material, they've just measured the energy consumed to do that, and they just report that, and it's got to be on a certain scale. So in some cases, you have to report it to us, but the source of it may be a third party, or it may be an outside third party. But in all cases, it is provided by the manufacturer. We don't have required third-party testing yet. Although we do some of our own third-party testing to verify compliance. So that's our testing issue. Any other questions there? Okay. Okay. So let's look at this real quick. So we've got first Energy Star product back in 1992. We've grown considerably over time in terms of scope and scale of Energy Star products. The label has become pretty ubiquitous. One of the elements of our labeling program, because it does focus on a lot of residential products, was we have a labeling program. We would like the manufacturers to put the label on the product. Now, with IT products sold into the enterprise space, that's not going to happen. That's not needed because it's a different way of selling products. But visibility is important, and we've created a lot of that through the requirement to make sure that products are in fact labeled. And we've now made it a requirement for IT products. It wasn't for the first roughly 7, 8, or 9 years. New Energy Star IT specs have come into place for all the imaging products, for the computer products, for the desktop and desk side varieties. And you will start to see a lot more labels on products we didn't before. So you'll see more of that. Here's just again a schematic showing all the major categories. This is probably not even exhaustive, but we probably have 13, 14 major categories of products, many different types of products in these various categories. And I think the one thing that probably makes sense, here's just an example. There are, I think, 6, 7, 8 different specifications for printers because not all printers are created equal, and so we understand that, so we broke them up. So when we're thinking about storage, clearly we would treat, even though in the future I hope there's a line that says we have Energy Star for storage, clearly it would be a lot more complex than just one line. Okay, so we've got some principles, some guiding principles that we developed 4 or 5 years ago because I think a bolt of lightning hit us one day when we were in a meeting not unlike this, and one of the manufacturers said, well, what are your guiding principles? And it seemed to make sense to me that we didn't really have something that we crystallized for people that would help them understand what we're trying to achieve with our specifications. That is, what are the things that our specifications have to represent or be embodied in the products that have the label. And so, cost-effective efficiency, what we mean by that is hopefully the payback, the rate of return would be reasonable for, let me re-explain that, the incremental cost associated with what makes the product more efficient, the cost for that would be, and the return on that would be reasonable such that it would make it cost-effective for the consumer. You couldn't, for some products, some of the HVAC products, some of the appliance products, the paybacks are considerably longer because the incremental cost differences between conventional and Energy Star can be pretty considerable sometimes. And so you have to allow for a longer payback. On some products where there's a very small difference, the paybacks can be very quick. And so really we're talking about cost effectiveness there. Performance, we don't want people to think an Energy Star laptop is inferior to a non-Energy Star, just because the Energy Star 1 goes to sleep very fast, but maybe has a lot of latency or other issues or problems associated with it. So we've got to have performance maintained or enhanced. Significant energy savings potential, that could be thought of both on a per unit basis, but more importantly, collectively for the product population. Nationally, we want there to be a lot of savings. So even though Energy Star laptops versus non-Energy Star laptops may only save a little bit per unit, given that there's so many of them, eventually it adds up to be real money. And efficiency is achievable with several technology options. We simply want to say that we're not going to write into a specification someone or a manufacturer's specific. We're not going to be technology specific. We're going to be neutral as far as that goes. So we'd like to see technology that's